Let's go unit vector. Big topic. Remember the unit circle? Remember that thing's kind of important, right, for trigonometry? When we're talking vectors, a unit vector is kind of important as well. I don't know if he's been able to tell you yet, but we can put vectors wherever we want to. So maybe you had some sort of vector v that's going this way. But you know what? We're talking unit circle. I want to keep this thing within this whole unit circle. You know what I mean? Like 1 unit long. Well, look at that. Vector v is just too freaking long. I wish we could have one that was just 1 unit long that just pointed in the same freaking direction. You know what I mean? Wouldn't that be? That might come in handy at some point in time. So we're going to want to take it and find out how can we make a vector, a unit vector. The point's in the same direction as v, but it's only 1 unit long. Its hypotenuse is, oh shit, I mean the magnitude's only 1. Because it can't be the hypotenuse, right? I mean, that wouldn't be helpful to make right triangles or something. We might know something about that. So a unit vector is basically taking longer vectors and just dividing them by however long they are. All right, there's a little quick intro. Let's get to it. Through all the bullshit we've done, hopefully you're not getting where to go from that. So quickly move. Here it is. We're talking about a unit vector. A unit vector is, well, we're talking about in the same direction as v. Remember what I drew before? So we want it to be in the same direction. We just only want it to be 1 unit long. Like, hey, I want you to go 5 miles north. And I go, oh, wait a second. You're only allowed to go 1 mile. So what do you have to divide 5 by to make it equal 1? Itself. It's however long the frickin' thing is. You just divide by that number. So that's what we're saying. It's like if you want a vector that's only 1 unit long, this is the same. So take your vector and then take your frickin' components and divide it by how long it is. That make any sense? Was that in English? I don't know. It made sense to me. All right. So take the vector, we divide it by however long it is. There's a unit vector. It makes it 1 freaking unit long. That's going to be super important, like a unit circle, a unit vector. Let's get it. Let's just see how it works. Let's start in on our first problem. We got 3, 4. So we got what, some sort of vector. What's it doing? Something like this. 3, 4. And we want to know how long this vector is so we can cut it down and just make it 1 unit long. So we get in there and be like, let's just have it be 1 unit long, maybe. I don't know. All right. Look at our right triangle we got here. A 3, 4. I wonder where the hypotenuse. Oh, shit, it's not the hypotenuse, it's the magnitude. We can't call it that, right? It's all frickin' triangles. They're all right triangles. Vectors, they just make right frickin' triangles, especially if you send them out of the dang origin. Make your life easy. We're good to go. So if we want to get a unit vector. All right, I'll stop beating around the bush. Let's get into the unit vector. It's saying we got to take our vector v. I'm going to write it out just a little bit differently. Go 3, 4, over. And we're going to take the magnitude of vector v. We're going to put it right inside of here. However long that thing is, we're going to divide by it. I know the formula says it looks like this. But, I don't know. I just say divide your components by however long the thing might be. So let's go find out how long is vector v. I don't think this is going to be too big of a deal. Let's see. Vector v's magnitude is, you should already know the answer. Just saying, like if you don't, oops. Look, I'm already trying to draw a freaking 3 in there. All right, 2, don't draw the 4. Squared, so it's 3 squared plus 4 squared is equal to, I do this 5. That's freaking 5. So why don't we just replace our magnitudes with 5? We're saying it's 5 units long. So if we cut everything and just call it 5. Oh, and we make this one 5. We're in luck. Look at that shit. Bang! Unit vector. Same direction. There's our unit vector in the same direction as v. We just had to divide that shit by 5 because it was 5 units long. Divide that shit, all the components by 5. Now, real quick, let's make sure this thing equals 1. Let's just the distance. Let's just make sure. I just want to confirm that the magnitude equals 1. Just a real quick thing. So wouldn't that be, if the magnitude is 1, that would mean these components would be 3/5 squared plus 4/5 squared. And if it is unit vector, then that shit equals 1. Find out what we got. That's a 9 over 25 plus 16 over 25. So 9 plus 16 is 25, and 25 over 25 is a square root of 1, which is equal to 1. Shit. Let's get it. That thing's got a length of 1. We found a unit vector in the same direction as v. Let's do another. We got some other vector. Negative 5 comma 6. So that's saying our x value is going to get negative and our y value is going to get positive, something like this that goes to negative 5 comma 6. Look at that beautiful freaking drawing I just did for our w vector. It doesn't matter. We're going to find out how long this dang thing is, and we're going to divide our components by it. We're going to keep the signs that we have because we want it to go in the same damn direction. We want it to point towards quadrant 2 where our x value is negative and our y value is positive. But oops, I'm talking about vectors, so it's just the components. Let's go get it. Let's get that magnitude first. So we're going to take our negative 5, we're going to square it up, and it's going to become positive. Take the 6, square that up, we get 25 plus 36 underneath this radical, and we get, holy shit, root 61. Okay, well, I don't know much about that number. All I know is it's bigger than 7, smaller than 8, but no biggie. Let's go find our unit vector in the same direction as w. So we'll say our unit vector is going to be, now let's write that in, our negative 5 comma 6, because those are going to be our numerators. It's still going in that direction. We just had to divide it by however long that freaking thing was, right? We just had to put this root 61 right down below. And there we got it. There's a unit vector in the same direction as v. And if you're one of those weirdos that has to do it, then well, fine, do it. Oops, that's not a 51, that's a 5. Oh, almost got it. 5 root 61, negative 5 root 61 over 61, and 6 root 61 over 61. If you're one of those freaking weirdos that needs to have everything rationalized. Whatever, there's the game. Find the magnitude, divide your damn components by it. Last one, just making sure we got this shit. All right, let's go find his magnitude. What's going on? Oh, this one's going first quadrant, so it's doing what? Something like this. 7, comma 7 root 3, whatever the hell that is, some sort of number. So, right, it's like a right triangle. Just trying to find out how long the damn vector is. So we can divide it by that, and we can just make it 1 unit long. All right, let's get its magnitude. It used to be that students had to be in classrooms. So I would make you do this with, make you show your steps and all this stuff. But you got to calculate. But I still want you to see the game here. Because it's going to pop out a lot. We're going to take our 7, we're going to square it. We're going to take our 7 root 3, and we're going to square it. I don't want to do the work here. This is 7 squared plus, and I'm going to bring the squaring just to the root 3. So we still have a 7 squared. I'm just going to put the square on top of the 7. But what's root 3 squared? That's 3. Just a little fun with math. We got 1 7 squared plus 3 7 squares. Gives us 4 7 squares. It's equal to 7 square root of 4. 47 squared, and then equal to 2 times 7, which is equal to 14. Well, that was a lot of work for something you could punch in your calculator, huh? But at some point in time, you might end up in a calculus class or something where your teacher does not let you use calculators, and you got to be able to show your steps. And even if you do have a calculator, a lot of the exact answers will be really rough to get. So you're still going to need to be able to play some of these games. So we found out that it was 14 units long. All right, so let's go get that unit vector in the same direction as vector v. So we're just going to take our components. We're going to make those the numerators, right? And our denominator is just going to be whatever the heck it was we found. There's that 14. Let's clean this thing up because that's just bad form. 1/2 comma. Oh, that's still 1. Huh. 1/2 comma root 3 over 2. I'm pretty sure we know that is going to, pretty sure we know that's going to equal 1 when we square them up, right? Because that's like, isn't that what, like sine of pi over 6, and that's cosine of pi over 6? Or, yeah, I think you know what I'm talking about. All right, I'll see you in the next one. Love the dog paws.